I would just like to go over two of the most missed problems on this previous exam. The first was problem number 6 on the white exam, which gave an IR spectrum and asked you to identify which molecule of the 4 was the closest match. The correct answer was 3, which was the alkene. Most people picked either 1 containing a carboxylic acid or 4 containing an aldehyde. And I would like to discuss briefly how we can rule out 1 and 4 from this discussion. Okay. First off, number 1 has an OH group, and there is no OH as part of the structure. We have a small peak here, but I had mentioned in class we're ignoring all these small peaks, and an alcohol must be very big. For example, from our class notes, here's an alcohol with the OH stretch that was very big. Moreover, I mentioned in class when we had a carboxylic acid, as shown here, this says example of a carboxylic acid, the OH peak bleeded into the CH peaks, and so you kind of had this big blob here. As you can see from the exam, this is not the same situation. So the number 1 can be rolled out on that alone. Number 4 contains a carbonyl group. Now there is a peak in the region where a carbonyl could be, and I think some were probably misled based on this chart. If you look at a C double bond O, it can be found from 1800 to 1600, and this peak falls in the 1600 region. However, it's not a carbonyl because it's too weak. Remember that carbonyl peak is very intense peak because it has a strong dipole, and the dipole changes the intensity of the peak. Let me again refer to the notes so you can see what carbonyl peaks look like. So here is an example from a ketone. You see how large that is. Here is an example from an aldehyde and how large it is. And then here's the carboxylic acid example, which again has a large carbonyl peak. Okay. So carbonyl peaks are usually, for C double bond O, more like 1650 to 1800. Okay. Around 1650, you were told that you would have an alkene and it would be fairly weak. The other giveaway is that an alkene should have an H, well, 3 H's, all connected to carbons that are sp2. And so the C sp2H should be at 3100. And you were told this from the notes, and you have that right here as your giveaway that you have an alkene at 3082. Okay. And aldehyde CH is at 2700, not down here, and you don't have anything peaking out at 2700. So again, to be able to distinguish these, the carbonyl peaks will have to be large. If you saw a large carbonyl peak, it would be between 1 and 4 that you're deciding. And then in addition, you would look for the OH region, or you would look for the CH region of this one. Okay. So make sure that you still review these ideas, and we will keep discussing IR throughout the remaining chapters. The other most missed problem was number 17 on the white exam, which asked you to indicate the hybridization, and most students chose B instead of the correct answer, which is D. And they only differ in this one right here, which deals with this nitrogen. Okay, so the nitrogen was throwing people off as being sp2. So again, in this type of drawing, you have to realize that the nitrogen's connected to what's before it, what's after it, and also the H. So in reality, this nitrogen looks like this and has a lone pair. And so that's 1, 2, 3, 4 areas, which is sp3. So you need to be able to realize this drawing scheme even though not all bonds are drawn out. For instance, this carbon still has 4 bonds, 1 to the nitrogen, 1 to the next carbon, and 2 to the H's. So this could be drawn out for bond line, or it can be drawn out and condensed as shown, or it could be given in an even more condensed form. So the more condensed form would be this: H2N, CH2, C double bond O, NH, CH2, CN. So you have to, in these cases, still be able to recognize the hybridization.